Population and samples. Population is the totality of all observation or individuals in the study. Size of the population indicates the number of observations in total. A sample is a set of observations selected from the population. The size of the sample is the number of observations included in the sample. In econometrics, the main focus is on probability sampling. An important type of probability samples is random sampling, where all samples have equal chances of being selected. Parameters and statistics. Population and samples are studied by the characteristics. Characteristics of a population are called parameters, and characteristics of sample are called statistics. Most important of these characteristics are the mean, variance, and standard deviation. They are denoted with these symbols in general. Variables, constants, and coefficients. Statistics deals with measures and counting. If what we study can be measured, it is called a variable. If something can only be counted, not measured, it is called an attribute. Usually, attribute shows the presence or absence of a certain characteristics in population. The opposite of variable is a constant. Unlike a variable, a constant remains the same at different points of time. A constant, if joined with a variable, becomes the coefficient of the variable. A coefficient may be symbolic rather than numerical. For example, in this expression ax, a is the constant. It is also the coefficient of the variable x. It is also termed as parametric constant and can take on any numerical value. Stochastic and non-stochastic variables. Some variables cannot be fully controlled or determined, so can only be described by chance or probability. These are known as random or stochastic variables. For example, stock market fluctuations and average amount of rainfall in a specific location. A non-random or non-stochastic variable has a predictable outcome such as time, speed, distance traveled by car, or the force of gravity of an object. Continuous and discrete variables. A variable may be continuous or non-continuous in nature. A continuous variable is a variable that can take any value on the numerical axis or part of it. Time, temperature, income, price, and expenditure can be classified as continuous. For example, time, that is, a race can be completed in 10 seconds, 10.5 seconds, or 10.75 seconds. Temperature, that is, a room can be 25 degrees, 35.5 degrees Celsius, or 45.75 degrees Celsius. Income can be 10,000, 50,500, 77,548.94. A discrete variable can only take specific values and whole numbers on the numerical axis. For example, number of students in a class. You can't have half a student. And the number of cars in a parking lot. Endogenous and exogenous variables. Endogenous variables originate from within. They are determined within the model by the forces external to the model. Exogenous variables originate from without. They are determined outside the models and their values are accepted only as input or given data. These endogenous variables are often stochastic. Exogenous are non-stochastic. Examples of endogenous are in a model of a firm's production, the quantity produced, price, and revenue. Whereas for exogenous, in the same model, factors like weather pattern, if they affect supply, or government regulations could be exogenous variables. The exogenous variables are also classified as instruments and non-instruments. Instruments are specifically manipulated to achieve some target. For example, government expenditure, taxes, and subsidies.